Hello Year 11, what is that? Welcome to a new mathematics video. It's me, Mr. Mistosh Mathematics, aka Mr. Stringer. I'm going to go through that past paper you've just done. In my opinion, yes, it was a tough paper. Don't beat yourself up if you haven't got full marks. It's very hard to get full marks on a paper like this. Take your time, try to make as many corrections as you can. Let's begin. So, first question. Factorising fully the following expression, you're looking at what's in common. Now I can see they both got a number which is common to both the left term and right term. 2 will go into both of those numbers, and p is also common to both of these, so you can take out a p. And now you have to think to yourself, 2p times what gives you 4p? 2. And 2p times what gives you 6pq? Well, if I multiply it by 3, that'll give me 6p, but I need to put a q there to make it 6pq. And of course, if you wanted to, you could multiply this back out to get 4p and 6pq. Expanding a quadratic here, I know that because it's a double bracket which is adjacent, i.e. it's touching right here. Now, a lot of you like the smiley face method. Some of you use FOIL. Either or, some of you use the box method, they're all fine. Now, if we do each eyebrow on the top, e times e is e squared. Positive 3 times negative 5, that is negative 15. I'm putting that on the end because I'm going to be putting the e terms in between. Here we have a positive 3e, and here we have a negative 5 times an e, which is negative 5e. That's 1 mark. I'm going to get a mark for collecting this. E squared minus 2e, take away 15. And if you know you're likely to make a mistake, we're doing 3 take away 5. Let's make sure we use a calculator. Solving the following equation with a fraction. So, y is equal to 2y plus 1, all divided by 5. Now I want to get rid of this fraction. I'm going to multiply both sides of the equation by 5. I will get that 5y is equal to 2y plus 1. Notice I have not multiplied the 2y plus 1 by 5 because I'm currently dividing by 5. If I then multiply it by 5, they effectively cancel each other out. So make sure you don't make that 10y plus 5, God forbid. Now, last step, let's get the y's on one side, numbers on the other. I'm going to move this 2y across to the other side by subtracting it because it's currently a positive. That's 3y equals, I've still got that 1 left over. My last step, divide by 3 because I'm currently timesing by 3 of y. Y is equal to 1/3. I don't need to write that as a decimal, fractions are just fine. And if you want to, you can put a third back into here. You should get a third equals 2 times a third, which is 2/3, and then do 2/3 plus 1, which will be 5/3, and then 5/3 divided by 5 is 1/3. Of course, you can check that with a calculator. Now onto your next page. Describe fully the single transformation that maps triangle A onto triangle B. Well, it's clear that it's going to be a rotation. In fact, if I get this and I twist it 90 degrees right, I'll end up with something along the lines of this. So I know it's going to be a 90 degrees clockwise rotation. 90 degrees clockwise rotation. You have to state the angle and the direction to get 2 of the 3 marks. To get the last mark, what point did it get rotated across? Now if I had tracing paper, I'd do trial and error here. There's another way to do it without tracing paper. If I go here, if I go along 4 up 1, I reach this point. If I go along 4 up 1, I reach that point. Not quite, maybe a little bit over here. If I go along 4 up 2, I get to there. So I've got like an L. Does it work here? Along 4 up 2. That L is exactly the same. This L here is exactly the same as that L. If I rotate that L round onto there like that, it will fit perfectly. That's another way to do it without tracing paper. So that's my point, my centre of rotation. So about the point -2, 3. -2, 3. Notice in a coordinate form, it's not in a vector form. Be careful not to do that. So that's an easy 3 marks you can pick up there. On the grid, translate triangle A by the vector -5, sorry. So I need to remember, this is how coordinates work. x is on the vectors work. X is on the top, y is on the bottom. So think about the x-axis. It's positive to the right. So I've got a positive number up here. Therefore, I'm moving it 2 units to the right. So it's going 2 units to the right. For the y here, this is a negative value. On the y-axis, the negatives are down the axis, going downwards. So therefore, I need to move it down 5 units. So just quite simply, pick a corner, any corner. I'm going to go for this one here. I'm going to move it along 1, 2, and then I'm going to come down 1, 2, 3, 4, 5. Up 2 squares, across 1, and down. And that is triangle C. An easy mark to be gained there. On the grid, enlarge triangle D with scale factor a half. For instance, here we are halving the entire area, and here's the center. So you pick yourself a target corner. I'm going to do this top left hand corner. No reason why. I go up 2 along 4. So if I was to do scale factor 2, I'd go up 4 along 8. I would double each of these, but because I'm doing scale factor a half, in fact I need to half each of these, because this is scale factor 1 for a half, and rather than going up 2 units, it would just be 1 unit, and rather than going along 4, bit across 2. So that's where the top left hand vertex would lie, this one here. Rather than it being 4 down, it's now 2, and then this was along 2, so it's now along 1. That was across 1 box up 2, so now it's going to be across, actually no, that was across 2 boxes up 4, so half of that will be across 1 box up 2. Yeah, that's fine. That's half of that, that's half of that, and that is half of that. Spot on. And now if you want to, with your ruler, just to make sure you've got these marks, some of you may or may not do this, but I would always recommend doing it. Each corner will match up with each corner when you go through this all the way down. That one looks good to me. That one looks good to me. Let's line up these corners. Does it go for the middle? Yes, it does. Brilliant. Right, so always double check. If you want to draw on the rays, you can. Another 2 marks there. Ooh, a probability question. We've got biased 5-side spinner, so that means they're not all going to be equal in probability. You can land on any of those 5 colours. All probability here will add up to 1. So I've got some missing probabilities here. When the spinner is spun once, the probability that the spinner lands on brown is 0.06 more than what it lands on yellow. So that's 0.06 more than that one. So worth remembering that. All probability adds up to 1. So brown and the yellow probability is going to be 1 subtract 0.15, subtract 0.26, subtract 0.33, 0.26. So the brown and the yellow is 0.26. However, we are going to need to do something with this, because you can't just half it and get 0.13, because that would be equal. So here's my recommendation for something like this. I've got 0.26. If I divide it by 2, I get 2 groups of 0.13. Now, I want one of these to be 0.06 higher than the other. So if I go up by 0.03 and I go down by 0.03, the overall gap then would be 0.06. Just to reiterate, by doing this with numbers, 0.13 up by 0.03 is 0.16, and going down would be 0.10. And you can see there, that is a gap of 0.06, and collectively adds to make 0.26. So brilliant. So the brown was more. Here's the yellow. Now that's the probability table filled out. Janine spins the spinner 150 times, work out an estimate. So the probability of it spinning yellow, is going to be what happens 10% of the time, i.e. 0.10. Let's multiply that by 150. If we do that on a calculator, we should get an answer of 15. Just to double check. So we'd expect it to happen 15 times. The table gives information about the price of gold. So on the 1st of February it's 1,126, then 1,236. So it's increased over time. Work out the percentage increase. Okay, yep. Of the gold between this day and this day. So I just need to remember percentage change. It's the difference between the two values divided by what it was originally, multiplied by 100 to turn that into a percentage. So I'll just say I'll put that percentage in green, because your outcome of doing this calculation is in terms of percent by multiplying it by 100. The difference, take away the old one, that's going to be the difference between the two values. Originally, what it was originally, you could just say, let's be a little bit better there, the original value was that, or the old value if you like. That'll give us a decimal / fraction. If we multiply that by 100, it will give us what our percentage is. It's just a case now inputting the values. 1236.5, take away 1126.5, divide 1126.5, oh, divided by 1126.5. We've got this decimal, we then multiply it by 100, turn it into percentage. 9 point, does it say here? Give your answer to 3 significant figures. So that's the first, that's the second, that's the third. The 4 will keep the 6 the same, rather than rounding it up. So that'll be 9.76%. So 9.76%. Oh, got a little bit down here. Now, just to reiterate, if we was to do 9.76%, or actually use the whole value there, 9.76475, 1% of 1126.50, we would see that if we added that on to this, we would reach that. So it's 9.76% increase of this to get to that. The price of 1 ounce of gold on the 1st of February was this. The price increased by 19% to July. What do we have here? March, okay. And work out the price of 1 ounce of gold in July. So it's just a case of realising if we start at 100% and we increase it by 19%, we want 119% then of what we originally started with. So we're going from our old price to get to our new price, remembering to multiply, not to divide. Now it's just a case of writing that in. So our amount, which was 1126.50, multiplied by multiplier. So this effectively is increasing it by 19%. 1126.5 times 119%. Some if you turn this to 1.19, the decimal version, but remember the decimal and percentage are equivalent. You can multiply it by 119% or 1.19, up to you. 1340.535. Work out the price of 1 ounce of gold. It gives you one to correct to the nearest dollar. So that'll be that nearest dollar. We're talking about the 0 there, the ones column. So that 5 will round that up to a 1. 1341. 1341. 1341. We don't need to put a dollar symbol. It's got the notation there for us. BCD, B to C to D, and AFE, A to FD are straight lines. Show that BCD, this line, is parallel to this line. Okay, well they're straight lines, so first thing, I know that this and this add to 180. That and that therefore will add to 180. And once I work out what x is from this equation, I could also say then if this line is parallel to this line, then this and this should be the same, or this and this add to make 180 because of co-interior angles or alternate angles. First statement to work out this, second statement then to prove that these are alternate or co-interior depending on what you want to do. So solving this equation, 34x plus 10 is equal to 180. Just collect your numbers and letters, subtract 10 from both sides. 34x equals 170. And now dividing both sides by 34, use a calculator for this part. We should get that x, well 10 lots is 340, so 5 lots will be half of 340, which is 170. X equals 5. Remember to use a calculator for that part though. So x is 5. So now if I substitute x is 5 into these three parts here, just to see, get a picture of what's going on. That one's 35. So 4x plus 15. Let's sub x equals 5 in. Give the reader a little bit of interpretation as to what's going on. That goes to 35. 30x minus 5 presumably is 145 because they add up to make 180. Let's check though. 30 times 5, take away 5, 145, and 20x plus 5 should be 105 because 20 times 5, add 5. I'll put it in bracket, I do prefer that personally. Oh, it's add 45. That would have been weird because then they wouldn't have been the same. Always be careful when you're copying things from diagrams to your own statements. 145. So this is angle A. So this here is angle between A to F to C. That's AFC. Just so examiners know exactly what I'm trying to do. 30x take away 5 is DCF. DCF. And this one is BCF. So really giving a picture as to what's going on here. Last thing to do then is to show that they're parallel. So BCF and DCF lie on a straight line. We haven't proved anything because it said that, but from using the fact they lie on a straight line, we could solve an equation, find x is 5, then putting that number into all three of these, we worked out what each angle is, and now it's a case of saying one of the following. You can either say that if these lines are truly parallel, then angle DCF and AFC will be the same because they're alternate. So angle DCF is the same as angle AFC. If lines are parallel. If the lines are parallel, you could even say BCD and AFE are parallel. If you want to be a little bit more precise. If the lines are parallel, because of alternate angles. Indeed, this is true. Indeed, AFC is equal to DCF. As you can see, they're both 145 here. Or you could say, alternatively, AFC and BCF, these two angles add up to make 180 degrees because of co-interior angles. BCF and AFC, they would add up to make 180. So up to you, whatever one you use there. Complete the table of values for this. I have a particular way in doing this. I know some people would substitute x as 1 into here. 1 squared, take away 5 times 1, add 6. There's nothing wrong with that, but sometimes students can make a mistake when there's negative values for x, so I tend to just use the table function. Mode 3 table. F of x is just it's function notation. Basically means y. Y is equal to x squared, subtract 5, x, add 6. Now I want to start the table at 0. These are for the x values. I want it to end at 5 for this particular one. I want it to go up in steps of 1. It's already got 1 in there. Equals. So when x is 0, y is 6. Yeah, we got that. When x is 1, y is 2. Oh, we're not going to write on a highlighter. Y is 2. And I need to scroll down the table a little bit. When x is 3, Yeah, 0, 0, we got that there. When x is 4, y is 2, yep, we got that. And when x is 5, y is 6. You'll notice here as well, this table is symmetrical about this point. So you're going to see some symmetry here. 0, 0, 2, 2, 6, 6. That's just a case of plotting it. X is 1, y is 2. X is 1, y is 2. X is 0, y is 6. X is 2, y is 0. X is 3, y is 0. X is 4, y is 2. And x is 5, y is 6. Now try to draw a nice smooth curve. One line. Beautiful. By drawing a suitable straight line on the grid, find estimates of for the solution of the following equation. So I've got x squared minus 5x equals x minus 7. Now, generally speaking, when questions are presented to you like this, if you look up, you've drawn a graph here of x squared minus 5x plus 6. So I want a plus 6 on this side. I'm going to put one there. And by doing it on that side, I have to do it on the other side. So I'll plus 6 here. Now I'm going to write it out. X minus 7 plus 6. Equals x minus 1. Okay, so we've drawn this parabola, or this bucket-shaped graph. That is there. And now we need to draw the graph x minus 1. If we draw that, they will intersect somewhere, and we can find that coordinate. So now we need to draw the graph y equals x minus 1. So set up a table. You could just substitute in some values yourself and find this out. Some of you will know that y equals x is just a diagonal line going through 1, 1, 2, 2, 3, 3, 4, 4, and then you just move, you just do a vertical translation down 1 unit if you want to do that, but I'll just show you how I do it just to make sure. Mode, table, x take away 1, starts at 1. Oh, we don't want it to start at 1. Press AC to get back to where it would start at 0, finish at 5 if I remember, going up in ones. So when x is 0, y is negative 1. When x is 0, y is negative 1. When x is 1, y is 0. X is 1, y is 0. Along 2 up 1, along 2 up 1. Along 2 up 1, you can carry on in this fashion. Along 2 up 1. And let's double check. So when x is 2, y is 1, x is 2, y is 1. When x is 3, y is 2. When x is 4, y is 3. X is 4, y is 3. Yep, that's nice. Let's try and get us a straight line going through here. This ruler is a little bit challenging. Well, this isn't quite going to be at 45 degrees because the graph scaled slightly different on each axis. I'll try my best here. I'll go for that. If it's by hand, it'll be a little bit easier. Oh, whoa. Okay, that's going to be a little bit out now, because everything just shifted. Can we undo? Possible to undo? Impossible. So, that was not nice because the entire graph is shifted on here. What we should have got, ideally, was a line going through. And we can see here there are 2 coordinates, here and here. You would then just need to find out what those coordinates are and just write those coordinates here. That would have been the idea. Unfortunately, the software decided to, well, I'm not sure, have a bit of a shocker there. So, table 7, question 7, talking about table. We've got a little bit of standard form here because these things are very large. So it says write this as an ordinary number. So it means here you can put this into a calculator, or you could just know that means move the decimal place 7 times to the right. That'd be 1, 2, and then 5 zeros. 7, 1, 8, 1, 2, 3, 4, 5. 71,800,000. Calculate the total volume. Well, I need to add this volume to this volume to this volume to this volume. I'd just like to point out this is actually, if we make that 10 times bigger, so if we make this 10 times bigger, make that 10 times smaller, this is 0.188 times 10 to the 8. I'm just going to make them all the same unit in base 10, so they're all to the power of 8. You don't have to, you could just put all of these 4 into the calculator. 0.718, make that 10 smaller, make this one 10 bigger. And then if you got the same unit, you could just add up all of these numbers here. So mode, put it back to regular computations. 0.188, add 3.1, add 2.64, add 0.718 equals 6.646. 6.646 times 10 to the 8. It's a really nice thing to do. And if you wanted to, you could again put all of these 4 things into the calculator, and it might give you it in this form, or it might give you in the extended form, i.e. 6646 with 5 zeros. The volume of the South China Sea, do we not have that one there? Nope. Is this, write it in standard form. So let's go back. 1, 2, 3, 4, 5, 6.88 times 10 to the 6. Isosceles triangle. That's nice because there's going to be a little bit of symmetry here, that means. With the height, perpendicular height, yeah. All these angles are the same also. If we need angles, we will see. The area of the triangle is 12 centimeters squared. Work out the perimeter. So we've got 2 formulas we could use. Either area is the base, the easy formula, base times the height divided by 2, or the area is a half AB sine C, where you know 2 sides and the angle in between them. Well, we don't know any angles here, so we don't need to use the more complex formula. So that's the perpendicular height, that's the base. The perpendicular height, however, we do not know yet. We leave that as height then. We know the area is 12, so 12 equals the base, which is 5, times the height divided by 2. So we can work out the height from here. Times both sides by 2. I'm going to get 24 is equal to 5 times the height. Divide by 5. And 24 divided by 5 is 4.8. Double it divided by 10 in your head if you'd like to. If not, use a calculator. So that's the height. Now we know the height. And we also know this is an isosceles triangle, so it's symmetrical. It's this triangle here. Right angle triangle. And there's also this one here. You can use whatever one you like, but if we are to draw just a quick sketch over here of what we're doing, this is 2.5 because it's symmetrical. You can half it, you can make that assumption. Finding the long side, i.e. the hypotenuse here. 2.5 squared plus 4.8 squared equals x squared. Simple problem for Pythagoras. Square root on both sides. 2.5 squared plus 4.8 squared is equal to x. I'm going to leave it in this form. You could, if you like to, actually write this out and then put it in a decimal if you're more comfortable. But that's a very long decimal, and if I round it because I feel like I want to, I will then use a rounded answer in further calculations and probably make an error, because when you round it you'll create an error, and if you use that error in further calculations it will start, the error will be multiplied by 2, etc. It starts getting larger and larger. So I'm just going to leave it like this. Nothing wrong with that. I'd rather write this personally than keep using that decimal version. So I've worked out x, which is this number here. So we've got that one. We've got the base. What does it want now? Work out the perimeter. It's just a simple case now of adding these 3 sides together. So I want 2 lots of x because there's 2 sides which are x. 2 lots of this thing. I need to add, so that's the two sides, I need to add the last side. This is the perimeter. Can we leave it like that? Oh, we can't, unfortunately. I wanted to 3 significant figures. So, fortunately, I've got this here. I'm just going to use the repay button. Already got it there. I want 2 lots of that. Add 5. Notice this is not in the square root. Be careful. If that goes within the square root, that is going to screw things up. So 2 lots of this, 2 lots of x, add 5. We get 15.824043, but we just want it to 3 significant figures. There's the first, there's the second, there's the third. The 2 will keep the 8 the same. 15.8. I think it's in centimetres. Yep. It's the perimeter. Just using triangle properties there to find the height. Table shows the information about the speeds of 60 cycles. Okay. Complete the cumulative frequency. So from 0 to 10 we had 3 people. From 0 to 20, so that's here, 0 all the way up to 20, we've got 19 people. And then here it says 0 to 30, so that's 0 all the way up to 30. Just keeping a running total. 3 add 16 is already 19. 19 add 24. 19 plus 24 is 43. And then the next box we need to go to is here. Add 10 is 53. Next box, add 5 is 58. And last box, add 2 is 60. So from 0 to 60, we've got in total 60 cycles. Let's just make sure. I think I did read that. Yeah, it's 60. Just know we've added things up correctly. Now what do we do? On the grid, draw a cumulative frequency graph. So we've got cumulative frequency there, speed there. When you're drawing this, you just need to pick the endpoints. So I need to plot 10, 3, 20, 19, 30, 40, 50, 60. So when the speed is 10, the cumulative frequency is 3. Speed is 10, cumulative frequency is 3. 1, 2, 3. Just check that's going up in ones. That's 10, that's 5. Yeah, that's correct. And then we've got 19 and 20. 19. Oh no, sorry, the cumulative frequency was 19. That was on 20. 43. The cumulative frequency 43. 30. 53 against 40. 53. 1, 2, 3. Then it's 58 and then 60 if I remember correctly. 58 is here. And 60 will be there. 60, 60. Yeah, correct. Now I just need to draw a nice curve. So obviously when there was 0 people, there's clearly 0 speed. We can assume that. We know that as a fact because there's no people, there's no speed. So you can always put that one in there. Some people start their curve here. There's nothing wrong with it. Sometimes you can get away with it on exam papers. But just to make sure, let's just make sure we're trying to draw a nice smooth curve. Ideally you would want to go point to point with a ruler here. I'm going to have to because it's actually quite hard to draw on this. But it's better not to do what I'm doing here and actually just to draw one nice smooth curve. Because this is going to be very sharp and actually will give some inaccuracies in the answer because from 10 to 20 it was not going to be this straight truthfully. Don't really want multiple line segments. And even then you can see there's some inaccuracies on this. Slightly below what it should be. I'm not really happy about that, but it is what it is. Right. Definitely not a smooth curve, but what can you do? On your graph, find an estimate for the interquartile range. So you need the upper quartile, subtract the lower quartile. That's where the 75th piece of data is, and that's where the 25th percent is. So 75% of data, there's 60 pieces of data, so 75% of 60, 45. want the 45th person there, and then 15th person, so this is the upper quartile. Lower quartile, it's just the difference between to get the interquartile range. Interquartile range just shows you where 50% of your data lies. 75% take away 25%, 50% of your data can be a useful value. So if I go along here, I hit to this point, go along here, I hit to this point, drop this down to there, drop this down to here, 32, call that 18, 32 subtract 18. It's 14. It's just worth noting, so 50% of the data, 50% of the data there, it's got a difference of 14 in the speed. So it's just worth noting here that yours might not exactly be 14, and that's really going to come down to the fact that this curve here might have actually gone a little bit like that. Yours might be a little bit below 14, a little bit above 14. You'll be given by the examiners in the mark scheme, they will give you a range of values which are correct. Here's a triangle ABD, and we've got actually a big right angle triangle ABD and a little right angle triangle ACD. AD is 13. This one, BC is 8, it's worth reading. This one is 8, not the entire length. Angle ADB, yeah, is 19, angle CAD is C to A to D is 20. Okay, calculate size of angle BAC, so B to A to C. We want this angle. Right, so if I could have this entire length and this entire length, I could use this big angle, and then once I've worked that out, I could subtract 20 and get that little angle. So all I need, what I'm trying to set up here is a soccer tower problem. I just like right angle triangles where possible. I know this one, I just need to find this missing little bit here. So if I am to draw out a little baby triangle to the right, just for or put it down here, that there, that's 20, that's 13, and I want to find this one CD, we can call it X. So labeling my triangle, that over there is the opposite, the hypotenuse the adjacent. Don't need the hypotenuse there, need to use tower. Times, so I'm trying to find O, I need to do tan of the angle times the adjacent length, that's O. Tan of 20 times there, 4.731. Well, I'm not going to round this yet, we already know why, because if I use this rounded version later on it's going to be a big error, but I'm just going to write 4.7316 dot 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 dot. That's what the O is, but I'm going to be using this in calculations again because I'm not losing any accuracy marks. So I've got this length, which is roughly about 4.7316, etc. Now we know the entire length here, 4.7316 at 8. So if I now set up the big triangle problem, so we've got the big triangle, that length there is 4.7316 at 8 dot dot dot, and bottom one was 13. I want to work out that big angle. It's another tower problem, OA. So I'm going to write down my tower triangle. I want to work out the angle, which is sort of trapped within here. I need to do that. Write this down. Tan of the angle is equal to the opposite divided by adjacent. So opposite divided by adjacent. The opposite is this plus 8. So let's put this into the calculator. This thing here plus 8, the entire side. I'm putting a bracket around it. So that length divided by 13 is equal to that. So 0.97935. I could write a little bit of that down. 735 ... And you must remember that's what tan x is equal to. I'm looking to get the angle, remember, so I need to take inverse both sides of tan to the -1 of the answer above. This, put a little degree symbol there, shift tan of that 44.4 0 241,282 241,282. However, that's the massive angle of the triangle, as in the big overall angle here. We don't want that. We want to take off 20 to be left with just this little bit. So what we need to do now to get angle BAC, it's just saying 44.4. So is that 20? It's going to be 24.4 degrees. One decimal place. It would make sense it to be one decimal place because we don't actually have a second there. So that could be an indication you've done the question correctly as well. So that was a double trig problem, soccer tower. Express this as a simple, a single fraction in its simplest terms. So if I multiply that by 2x and multiply that by 3, just opposite, so that'll make sure that I get a lowest common denominator, not a lowest common denominator, a denominator what they both go into. So remember, multiply the entire side by 2x. So 5 times 2x on the top is 10x. Times the entire top by 3. That's going to be 3x plus 6. Now they're both over 6x. Now it's just a case of, if I'm to say something like 7, 6, subtract 5, 6, you only subtract the numerator, remember? So 10x subtract 3x. Yeah, I could write it a little bit more explicitly so someone doesn't make a mistake. 10x, take away that entire right hand side, which is actually, expand that bracket out technically, minus 3x minus 6. I know for a fact a lot of people will make that mistake of putting that as a plus 6, but it's not, because technically this is plus 0, and it's 0 take away 6, just as it's 10x take away 3x, it's 0 take away 6, so it will be a negative 6. I prefer to put in a bracket just so I never make that mistake. So simplifying the top, 7x take away 6 over 6x. I can't cancel it down because 7, 6 and 6 only have 1 in common. The curve C has an equation y equals this. Find dy by dx. This is a calculus problem, so in order to start setting this up, you need to remember, how do you find a derivative, as in dy by dx. It's just a case of doing this. If, remember, you have a term like this, all you need to do is bring the power to the front and then take 1 away from the power. So it'll be 4x cubed, for instance. Another one, so add 5x squared, you bring the power to the front and take 1 away from the power. And then you could do it again, take the power, bring the power to the front, take 1 away from the power. Yeah, just remember that. That's how we differentiate. So bring the 3 to the front. 3 times a third is, well, 3 times a third is 1. Don't need to write 1 there. Take 1 away from the power. That's x to the 1. Bring that down to the front. 9 times 1 is 9. Take 1 away from the power. That'll be x to the 0. Remember, anything to the 0, power 0 is 1. That's technically a constant. When you differentiate a constant, nothing happens to it other than it disappears. So we've got x squared minus 9. Find the range of values for x. Remember, this is talking about gradients. Of course, you've got different gradients, very steep, not steep, getting steeper, very steep. It's talking about all the different gradients you can have on there. The gradient of a straight line is constant throughout. You're constantly walking up a hill, you're constantly walking down a hill, etc. But there's lots of different gradients here. So say we've got a, well, this is a cubic function, as you can see up here. It's got a cube, so it looks something like this. Find the range of values for x. So I'm looking along here, for which it has a negative gradient, so we're looking down at this bit. Find this range of values, and the way you find that range of values, you say, right, I want this here. Remember the following. happy, sad, and sad is less than 0. When you're unhappy, that's how you get negative gradient. So I want my function here, the gradient, I want it to be less than 0. Now solving this. Difference of 2 squares. Alternatively, what you could think of, by the way, that there, remember you're solving quadratic, that's x squared plus 0x minus 9. Two things, what times to make minus 9, but add to make 0, plus 3 and minus 3. If you didn't spot, it's a difference of 2 squares problem. So you want all of the range of values which are bigger than 0 here. So if I was to imagine plotting this, let's do like a simple cubic as a quadratic. We want everything which is all the values which are greater than 3. No. So here we've got a cubic, and then we wanted this portion here. So say that's negative 3, so that's positive 3. We want everything in between, so we want x greater than negative 3 here to get that little slice. We want x less than 3 here. So we want x greater than negative 3, but less than 3 to get this portion where it's negative gradient. Find the range of values. Yeah, there your range there, for which has a negative gradient. All the students in year 11 at school must study at least one of these. There's 65 students in total. Okay, I always like to start with everything in common to all of them. So we've got geography, history and religious studies. What one, where is it they study all together? Ah, here. There's 15 will study all 3 of them. Okay, give that a tick. 21 study geography and history. Geography and history. Remember though, we've got 15 of them already studying geography and history here. Although they study RE, they still are studying geography and history. So we only need 6 there. That'll make our 21. Because if you look at this portion here, that's to both geography and history, regardless of whether RE is there or not. 16 study geography and RE. Geography and RE. It was 16. I've already got 15 studying geography and RE here, so we just need one more. 30 study geography. That's just only geography, nothing else. So I've already got 15, 16, 22 here. So I'm going to need 8 more. So the geography circle should equal, when you add them up, 8 plus 6 plus 15 plus 1. 30 as it says. 18 study only RE, so RE is down here. 18, we've got 16 here for the RE part. This is the RE portion of the circle. So we're going to need 2 more. Rub out. And 37 study only religious studies. Study only, so it's 37 study religious studies, so it's 37 in total for the RE circle. 37 in total. 37. Take away 1. Take away 15. Take away 2. 19. Oh! I skip one. I did, didn't I? So have a look here. When I put that 2 there, that was saying that there's so far 18 who study RE, but this says 18 study only RE, or religious studies if you like. That's not saying that 18 only study RE, that's saying that 18 in total study RE with geography, with history. But to have 18 study only RE, this little section here, if we imagine that bit there, that's just the RE bubble. That'll make a little bit more sense. So 18 study, that makes more sense. 37 study RE in total. So that's this bit, and this bit, and this bit. That whole total should be 37. Now that makes a little bit more sense. 37, take away 18, take away 1, take away 15. There's 3 somewhere. Well, it can't be in here because we've already got that piece of information here and here. 3 must study RE and history. Got any more information? We did know that there were 65 people. It doesn't say the students who don't study, they don't study any of them. There's probably that indicated in the question, which I misread. All of the students, they must study at least one. So there's 0 there. You probably get away with not writing 0 there, but just for argument's sake. So we know there's 65 in total. Let's just have a little look. What's just in the history section? 65 take off. I'm going to work from the bottom to the top. 18 take off 3, take off 15, take off 1. Oh, 18. Oh, let's check I'm not screwing this up. 65 take 18, take 3. Yep. 18, 3, 15. Take 1, take 6, take 8, 14. And then if we're correct, these numbers, 8 plus 6 plus 14 plus 1 plus 15 plus 3 plus 18 add up to 65. Okay, I'm happy with the Venn diagram. A student in year 11 who studies both history and religious studies is chosen at random. So we're only looking at a specific amount of people here. Both history and religious studies. History and religious studies. So that's this part. They both do history and RA. Doesn't say not geography, it just says work out the probability that work out the probability the student does not study geography. So of the 18 people, there's 18 there, what we're looking at. What's the probability that they do not study geography? Well, take that bit away. It's 3 of them. Put that into a calculator and get a sixth, which would be fine. Just like that. Or you could put 0. I think it's 16 recurring. 16.6%. It's up to you. 1/6. Don't mind how you have it. Any of them are fine. All will be fine. You can leave it as a percentage decimal fraction. They are equivalents. T is directly proportional to the cube of R. We can say that. And directly proportional, remember, to get to there, you just need your constant. T is 21.76 when R is 4. Substitute that in. So this will allow us to find our constant K. 21.76 equals 64 times K. K 4 cubed. 64. So, don't want that dot there. Let's just find what K is. Divide both sides by 64. 21.76 divided by 64 is what K is. Again, we could work this out, see if it's a nice decimal. If it is, we'll write it out. If not, I'll leave it as a fraction. Is it a nasty decimal? Oh, it's 0.34. That's not too bad. It's not recurring, it's not irrational. I like it. So that'll be our first few marks for finding that constant K. 0.34 times R cubed. So we found that. If you can't write this statement though, you're already losing the battle. So just remember when it says directly proportional, it's your constant times, say, R cubed here. If it was the cube root of R, you'd write the cube root of R. If it's indirectly proportional, it's K over R cubed. You just have a fraction instead. Work out the value of T when R is 6. So T is equal to, I've got my constant K, 0.34 times R is 6, 0.34. It is 73.44. Any rounder needed? Nope. On to your next one. The total surface area of a solid hemisphere is equal to the surface area of a cylinder. Now this particular one, total surface area of a solid hemisphere, so that's half of a sphere, half of a sphere. So we've got this on the formula page, we've got this on the formula page. The radius of the hemisphere, so we've got our hemisphere. I'll have a look at this in a minute. Wouldn't expect you to know this off by heart. That's the radius. Hemisphere. The radius of a cylinder is twice the radius of a hemisphere. So we've got a cylinder. That's poorly drawn, but you get the point. This radius of a cylinder is twice the radius of a hemisphere. So that's 2r. Okay. So let's see if we got the surface area. We'll probably be given the surface area of a sphere. We'll have to half the surface area of a sphere to get our curvy part. And we have to add on the surface area of a circle, pi r squared. That'll be the surface area of a hemisphere. And we should be given the surface area of a cylinder. Just going to have to zoom out here to scroll up quite a few pages. And then hopefully should be able to remember what's going on. If this wants to load. Oh, actually, good thing I've got a formula page right next to me. I can just write them down. Save the hassle of it having to load and not load, should we say, because it's definitely not loading. No, where's our formula? Gotcha. So it says here, actually we've got them beautiful sketches. It says the curved surface area of a cylinder. So does it say curved surface area of a cylinder? Yeah. It's 2 pi RH. Oh, it's the curved surface area of a cylinder, which is this bit. It's not talking about the end bit, so we've not got that. The total surface area of a solid hemisphere, so yeah, that's definitely including the circle as well as the curved part, is equal to the curved. So you've got to be really careful not to add on 2 pi r squared to this one for both circles on each end. So that is equal to, well, I'm going to put a capital R because that's the radius of the cylinder, which is not little r, that's big R at the moment, that's the radius. Because if I put R, it's not actually R, it should be 2R if we're talking in terms of the same radius here. And then the surface area of a cylinder, it says 4 pi r squared is the surface area of a sphere, so we have to half that to get 2 pi r squared. I have to add pi r squared on to get the top part of the hemisphere. So this is our cylinder, and this is our hemisphere. Remember, r is actually 2r, so 2 pi 2rh. Collect them together, 3 pi r squared, 3 lots of it because that's one lot, 4 pi rh, 3 pi r squared. So, let's have a think here. What is the height of the cylinder? Do we know this yet? Or is that how we will leave it? So the height, if we imagine we've got that net, you do not know the height, not yet. Okay, so 0, take 4 pi RH off both sides, 3 pi squared minus 4 pi RH. We could say that if we like, or we could say that, happy at both points. It says, given that the volume of a hemisphere to the volume of a cylinder, so hemisphere, oh, we've got the volume of it, oh, we don't have the volume of the hemisphere or volume of a cylinder yet, but we've got this little statement here for a moment. So that bit there was the cylinder surface, and that bit there was the hemisphere surface, so I'm just going to put that there. We can't do much with it yet because we've got 2 variables, r and h, and 1 equation, so we can't solve it essentially. But this piece of information might help us. Volume of a hemisphere, let's have a look what that is. It says here on the formula page the volume of a sphere, so volume of a sphere is 4 over 3 pi r cubed. So of a hemisphere, it's going to be half of that. Divide it by 2, 4, 6 pi r cubed. You can just think about doing 4/3 divided by 2. Ah, what have I done there? Of course, I've times it by half, haven't I? Which, just double check. 4/3 divided by 2, 2/3. Me being an idiot. Right, always double check. So that's the volume of a hemisphere. Now we need the volume of a cylinder. I think it said that there. Volume of a cylinder, which is pi r squared h. Volume of a cylinder. So just using the formula page at the moment. Pi r squared times the height. Now it says, what can we do with it? It says if we do that to that, this to this, it's equal to 1 to m, equal to 1 to m. Well, we currently do not have a 1 on this side, on ours. That's got a 1, that's got a 1. If we divide this bit by 2 over 3 pi r cubed and that bit there, we'll get a 1 there, because anything divided by itself is 1. So just to reiterate what I'm doing, I'm just dividing it by itself. What you do to one side, you do to the other. Think of it as an equation there. So 1 to, oh, see how messy this gets, over 2/3 pi r cubed. Now we can do some cancelling here, I believe. Got a pi there, I've got a pi there, got an r squared there, r cubed. We've got 1 h over 2/3 r. This is technically 1 divided by 2/3. 1 on the numerator divided by 2/3. 3 over 2, which is 1.5. 1 to 1.5 h over r. That's just another way to look at it. I prefer that. So m is equal to this. M is equal to 1.5 h over r. But we haven't actually used the surface area yet, so we could probably use something here. If we get, let's think, we could get h here on its own, and then substitute h in over here, so we don't have to have that there. So if I want to get h on its own, make h the subject. Let's add 4 pi, so we get back to this point here. Yeah, back to that one. 4 pi rh equals 3 pi r squared. Just divide both sides by 4 pi r to get rid of that bit to the other side. I'm going to get that h is equal to 3 pi r squared over 4 pi r. That's what h is. Again, a little bit of cancelling. We get that h is 3r over 4. Let's put that h all the way over here. M is equal to, does it want it in terms of r? Does it say? Nope. M is equal to, well, it doesn't say leave it in terms of r or leave it in terms of h, so I'm just guessing the numbers are going to cancel out here. 1.5 times 3/4 r over r. That's what h is over here. I'm not going to do 1.5 times 3/4 of my head because I really don't need to, especially at this stage. Might make a mistake. 9/8, 1.125. 1.125 times r over r. And would you look at that? The r's cancel out, and m is equal to 1.125. Tricky, tricky, tricky question. Scary question, in fact. So, I mean, my advice for that question, take your time, read the formulas. Can I insert something? I realised, oh, I haven't actually used that surface area. What could I do here? I thought, well, I could put that h into the other equation. Maybe something will cancel. Maybe I'll be left with a number on its own. Fortunately, there I was. rationalise the denominator. Remember the way you rationalise things. So all you need to do is to multiply it by the opposite sign of the denominator. Sort of a difference of two squares result. Okay. So you multiply this by the opposite sign here. Create a beautiful little proof. Well, not proof, but idea. Because you're technically multiplying, this is just 1 something. This a plus 4 root b divided by a plus 4 root b is 1. Multiplying it by 1, I'm not changing the value of it. It's just trying to do a little bit of algebra. Expand the top smiley bracket. Expand the bottom smiley bracket. A squared plus root 4. If you do root 2 times root 2, it's technically root 4, which is 2. If you multiply a root by itself, it just pops the number out which is within the root. Nice thing to do. So when you do root 4b times root 4b, it's just going to be 4b, and then bottom eyebrow a times root 4b, the mouth, and then the chin, plus a times root 4b. We've got two lots there, as you can see. The bottom one's a difference of two squares. We'll be getting a squared minus 4b. You could expand the bracket out again, get a squared here, minus, and then root 4b times root 4b, just pop it out, it's 4b, so it'll be minus 4b. Then you got a negative a root 4b times a, and then a positive a root 4b, which cancel each other out. If you're wondering how I did that, that's the difference of two squares, so remember this result. Where that bracket is these two here. Tidy up the top part of this fraction. A squared plus 4b plus 2a 4b over a squared minus 4b, which is a lot less complex than the original expression here, because we don't have a square root in the denominator. Given that, ooh, we've got index laws. So remember, y to the half, x to the half, because you are square rooting the entire fraction, so that applies to this and this. The square root of something is actually, you can write that there. Remember, roots, like on trees, look at this bad tree, we're on the bottom, that's the square root, so it's on the bottom. Power to -5. That is actually, let's flip or invert if you like, find the reciprocal of if you prefer to a posh language there. So firstly, deal with the negative part by flipping the fraction, and then apply the power law where you multiply the powers. Remember, x to the m all to the power of n is actually x to the m times n, so multiply, do a half times 5, which is 2.5, or 5 over 2 if you like, because a half, which is 0.5 times 5. So that looks like that, where x is not equal y. Okay, find the value of m. M is 2.5. Here is a triangle ABC. Find the value of x. So I can't use the sine. Remember, we can't use SOHCAHTOA here. It's not a right angle triangle. Cosine rule or sine rule, one of them. Unless we're using the sine rule for the area, but it doesn't say anything about the area. I'm trying to find out an angle. Side angle side. Cosine rule I can't use there. Do I have a side and an opposite angle and a side and an opposite angle to use the sine rule? Sine rule. Side and opposite angle, yes, but I don't have a side and opposite angle given. So I basically, if I worked this out, I'd have a side and an opposite angle known, and a side and an opposite angle known. So I could use the sine rule second. First, cosine rule. Cosine rule, you need a side angle side. Side angle side. That'll work out the opposite. And then we use the sine rule. So multi-step here. Quite a hard problem. Call this, am I going to call it x? Probably not the best idea. I'm going to call it b, opposite big B. So you can look at the cosine rule on the formula page. That side squared is equal to the other two sides squared. Subtract both those sides times together. Cosine of the angle. So b, the square root of all of that. What's a? A is opposite this one, 5.3 squared, plus the other one, 4.1 squared. This one and this one. Subtract 2 times 5.3 times 4.1 times cos of the angle 110. That is a long thing. Chances are that is going to be a very long decimal. I'm not going to put this into a calculator, get it in decimal form, use that in future calculations. I'm just quite happy to put this into my calculator. We can sort of check that ourselves. Plus squared minus 2 times. I don't say I always. Most of the time I make a mistake here. So I'm going to find out where I have in the calculator. So I've got cos 110. As I said, that I actually did make a mistake. That's 4.1. That would have been horrendous because that would have been massive. 5.3, yep. 4.1, yep. Minus 2 times 5.3, yep. Times 4.1 times cosine 110. That's in the calculator. That's the decimal if you want to put it as that, but why would I want to do that? Potentially making an error. So that's B. I know this now. So the sine rule, you need a side and an angle, and a side and an angle. Yes, we've got that. And side and an angle. So I'm trying to find an angle, so I want that on top. This also is on the formula page. Let's do this in red. Spice things up a little bit. So I'm trying to find an angle, so that'll go on top of my formula. Over the matching side. So let's put that as capital X and let's put that as capital A, because if not, that indicates that that X and that X were the same, which they're not. So sine X, we don't know that yet, so we leave that. We know its opposite side, which is 5.3. Sine A, the other one, what we're using is this one, sine 110, and its opposite side. Oh, that's rubbish. Here, square root of blah 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 blah. Obviously don't write that to the examiner. Square root of answer, or square root if we like. We assign this B, we can call that B. That's a big number though. Times both sides by 5.3. Sine X equals sine of 110 over square root of that big thing we found times 5.3. Last step, we want to find the angle, so we need to find the inverse sine of both sides to move that across. Sine of 110 divided by square root of B. Just leaving it all unchanged until the last possible moment. X is equal to, now let's get this into the calculator. So on the top was sine 110 divided by the square root of B. Oh, it wasn't the square root of B. We just want the opposite length, which is just B. We don't want that there. So the square root of blah was actually fine. Square root of blah 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 blah. Square root of blah. Square root of blah, which was that 7-point long, really long decimal. So square root of blah 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 blah, which is actually B. Let's get that back in there. Divided by that really long decimal. Remember, we stored it in the calculator, so that is our answer at the moment, which is really good to use. Times 5.3. We get 40.10. We're not going to need all that. Probably got some sort of significant figure. 3 significant figures. So X is equal to, well, that's the first, that's the second, that's the third. 40.1. Okay. So just checking everything looks good there. Yep, we use that. 110 at that opposite side. 110 the opposite side. Where the opposite side was that square root. Let's press up on the replay button. It was 7.73. Well, let's have a look. 7.73. If I use that in here rather than the accurate one, what does it do? Does it change it much? 40.11 rather than 40.10. So to 3 significant figures, this will still stay as 40.1. But you can see how that's changed that massively. So don't use rounded answers, because then you introduce this massive error afterwards. Worth noting. Showing the grid. Scratch this. So let's just pick a point when x is 4, y equals f of 4. What is that? What's the function evaluated at 4? Y is 5. 5 is equal to f of 4. We know that. That's a point. I like this one because it's on the corner of a square. Let's go down here. So I want to get that same thing. Y is equal to, I want that to be y is equal to f of 4 for this new graph. Y is equal to f of 4. How do I get that? I'm going to have that as 8, aren't I? Because that needs to be a half times 8 to get 4. So x has to be 8 here. When x is 8, all the way over here, then I'll get a 5 because I needed a 4 to be inserted. So in fact, every point, if you look here, is being stretched outwards. You would think because it's a half it's stretched inwards, but no, it's actually not. So using that idea, I've got here 3, double that to 6, that'll be over here. This is 1, double that, 2, where's the next whole number? Here, -1, double that, -2, and -2, double that across to -4. So we should get a nice symmetrical graph. Try and make sure this is as smooth as possible. Probably can draw it better than me. That's how I'd say that's looking. If it looked more like a bucket, more like a parabola, so effectively it's being stretched, going out. And now, what's it asking? Y is equal to f of x plus k. So this point here is at 1, 5. It originally was at 4, 5. So it's been shifted back 3. So originally y was equal to f of 4. That gave us 5. Where x was 4. Now it says y is equal, so if that was 1, that would have to be 3. K would have to be 3 in order to get f of 4 there. So it's been shifted to the left. K is 3. G is the function with domain x squared and 3. Oh, this is quite a tricky question. So the domain, if I put x is -3 into here, that will give me the range of values, what the function can take on. It's asking me to write down the range of the inverse function. So that's a bit of a trick question because that's just the domain of the original function. That can be quite tricky. If you're not used to function notation, that's fine, but the range of the original function, g of x, is the range of values it can take on. And the way in which you can work that out, you can put -3 into here. That'll be the minimum value, and it's open-ended, so all the values beyond that will be the range. So the smallest one, -3 squared, which is 9, plus 6 times -3, -18, 9 add -18, which is -9. The smallest value it will be is -9, and so on. That's the range of that function. In terms of the graph, it will look like that, where -9's at the bottom, and it will keep going up and up and up and keep growing and growing and growing. As you can see, that grows. But the range of the inverse function is the domain of the original function. So you just need to say the range of values are these. Express the inverse function. So this is sort of like write g of x as y, and what you're essentially trying to do is make x the subject here, get x on its own. Now this is quite a tricky problem because you can't actually get x on its own here in a couple of steps. If it was like this, if it will let me rub this out. No, I'm scribbling it out because why not? It won't work. Oh, it will work. It rubs out everything bar the scribble. How hilarious is that? So, if you scribble that part anyway, to make x a subject here, you just square it both sides. You get x on its own. That's quite easy. However, we can't do that here. We've got that x squared plus 6x is y. So, in order to get x on its own here, you have to complete the square, which I think is a very, very tricky part to notice on this question. Half the coefficient of x here is 3. If you now have to square this and make it the negative version of it, so 9. It's always a negative, in fact, because if that's a negative number and you square it, it will still be a negative when you say it's the negative version of it. If you expand this bracket, x squared plus 6x, take away 9, that's a plus 9, isn't it? Is it? Is it not? No. Like I said, it's a negative 9. So, yeah, x squared plus 6x plus 9. Take away 9, it will end up going back to this. The completed square version is so useful here because of the following fact. When you add 9 to both sides, you get y add 9 equals x plus 3 squared. You can see you can start unpicking x now on its own by firstly the whole thing's being squared, so square root it. Square root of y plus 9 is equal to x plus 3. You can now take 3 off both sides, subtract 3. That was quite hard in that you could unpick it slowly. If you don't complete the square here, you can't actually get x on its own, so that is really tricky. You've got to remember though, this is the inverse function. This is not g of x, this is g minus 1. Just remember to replace the y as an x. Things will be satisfied there. You remember it said, so the range of this, which is the domain of the original, if it's up here, says that x is less than or equal to negative 3. Oh, it's crashing. Don't do it. We're only like 1 or 2 questions off. Is that right? Yeah, so the domain of this, is the range of the original. The range of the original, if you remember I said negative 9, add 18, 9 subtract 18, which is negative 9. You can see here that you can't put negative 9 into this because you can't go lower than negative 9 because then you get like negative 10, negative 11, etc. You can't then take a square root of a negative number for real values here. So that's also worth noting. So we can pop that down there. This negative 3 plus square root. Remember, square roots do actually have a plus or a minus there. A bowl contains n pieces of fruit. Of these, 4 are oranges, the rest are apples. Okay, so n take 4 and 4. That's our apples. This is our oranges. 2 pieces of fruit are going to be taken at random from a bowl. Are they then not going to be replaced? I'm assuming they're not going to be replaced. The probability that the bowl will then contain n minus 6 apples, so that means you've taken 1 apple to get it to n minus 5, and then you've taken another apple to get it to n minus 6, so this is the probability of getting 2 apples in a row is a third. Okay, work out the value of x. Well, let's go for apples, oranges, apples, oranges. We don't really need to go down the oranges. That's a bit of a weird one. Let's not spell apples like oranges like that. Apples, oranges. You don't need to go down this branch. We're only interested actually in getting an apple then an apple here along there. So if we think about how many apples there are, it's n take away. It's not going to let me rub that out, is it? N take away 4 over n because there's n pieces of fruit. If I then take another apple, it's now n take away 5 because there's 1 less over, this is a total minus 1. That's the branch we're going for. You'd have to think about the other branches, but it doesn't really serve much of a purpose here. Remember, moving along probability trees, you have to multiply to find probabilities. I definitely did click on the red pen there, not the yellow, so God forbid why it did that. So n take away 4 over n multiplied by n minus 5 minus 1. So this probability is equal to 1/3. 1/3. So work out the value of n. Let's just double check that this is set up correctly, because the worst thing to do is to solve an equation that hasn't been set up correctly. So there was n take away 4 apples. If we eat 1 apple, it now goes to n take away 5. We could check that other value. So if there was 10 apples, if there's 10 pieces of fruit, we'd have 6 are apples, so it's 10 take 4, and then 4 will be oranges, and then if it was n take 5, it'd be 10 take away 5. Yeah, so n take 5 would be the correct thing. So just trialing out of a number there, that can always be helpful. That there is utterly useless though. Just to make sure everything's set up fine. Now we can solve this. Multiply top part, multiply the bottom part. n minus 5 times n minus 4. I don't know why I swapped that around, but it's commutative, so it doesn't matter with multiplication. Equals a third. Expand the bracket, smiley face on the top. Classic. We've done that so many times this process. We should be brilliant at it by now. N squared plus 20 minus 5n minus 4n over n times n, which is n squared minus n. That's a third. Let's tidy the top up a little bit. N squared minus 9n plus 20 over n squared minus n equals a third. Now we can cross multiply because we have two fractions. This multiplies to this numerator, this multiplies to this numerator, effectively times in that side by 3, times in this side by n squared minus n, times 3 both sides, that gets rid of that, times both sides by n squared minus n. Put a bracket there. So 3 times n squared minus 9n plus 20 equals n squared minus n, because we're multiplying n squared minus n by 1, 3n squared minus 27n plus 60 equals n squared minus n. 3 doosh doosh. Take n squared from both sides, that'll be 2n squared. Add n to both sides to get 0, so that'll be negative 26n. I'm only doing this because I can't really fit much else below. 2n squared minus 26n plus 60 equals 0. Divide everything by 2 because they're all even numbers. 2n, so sorry, n squared minus 13n. Oh, it's just turned to black. Nice little colour change. Two numbers that times together to make 30, but add together to make negative 13. Well, they've got times to make a positive, but add to make a negative. They're both going to have to be negative. So I'm thinking 30, what about 10 and 3? Negative 10, negative 3, yeah. N minus 3, n minus 10 equals 0. So n could be 3 or 10. Well, that's weird. Why is it giving us two answers? So remember here, something times something is 0. This, to make that 0, n has to be 3. Or to make this 0, n has to be 10, because 10 take 10 0, or 3 take 3 is 0. I'm not really sure what one to pick here though. Well, let's have a look at the question. Oh, that makes sense now. Remember, 4 are oranges. You can't have then that we have 3 oranges in total. That doesn't make sense. 3 pieces of fruit in total, because then if you have 3 pieces of fruit in total, but 4 oranges, how does that make any sense? It doesn't. So 10 therefore must be, there must be 10 pieces of fruit. 10 pieces of fruit in total. That's quite cool. But just to check, if we do, if we have, then if 4 pieces are, so let's do a quick check. Best thing in the world. So if 4 are apples, 6 then would be oranges. Am I getting that the right way around? Won't let me scroll up anymore. 4 oranges, the rest are apples. No, sorry. So 6 apples out of 10 times, then if we eat 1, 5 apples out of 9, because you didn't replace it, because you've eaten it, I guess. It could be 30 out of 90, which is 3 over 9, which is a third. That's the third. That's the probability of getting an orange and an getting an apple then an apple eaten. And it did say in the question that it is a third. So that's a really nice check there. Last question. I know this has been long. If you've stuck with me this long, hats off to you. Arithmetic sequence, just seeing that there, that means there's a constant difference. So for instance 5, 7, 9, 11, etc. That's a constant. Add 2. It's a constant difference between each term. That's what that means. So there's a constant difference. D for difference. Prove that the common difference of the sequence is 12. So I'm proving that. So that's what I have to end up with. I do not use that at any point. So this, remember, difference is the big number take the small number. For instance here, 7 take 5, 9 take 7, 11 take 9. So this here, 20x minus 52, subtract 8x plus 2. That there, that difference should be equal to the middle one, subtract the first one. Middle term subtract the second term, subtract first term. 8x plus 2, that difference, sorry, this difference of the third and second term should be equal to the difference of the second and first term. Okay, now it wants to go in red. It's going crazy today. So let's just expand this bracket out. The negative attaches to both symbols. So negative times positive is negative 8x, negative times positive 2 is negative 2. 8x plus 2 minus 2x minus 23. Remember, negatives attaching to both. So I've got collecting everything here. So 20x and a negative 8x here is 12x, negative 52. Subtract 2, negative 54. 8x and negative 2x is 6x, plus 2 take away 23, negative 21. Let's move the x's to the bigger side, take 6x off both sides. 6x minus 54 equals negative 21. Add 54 to both sides to move it across. Negative 21, add 54. Difference of 33, I believe. Yep, difference of 33. So 33. Let's check that. It's getting late. Oh, negative 21 and 54. Okay, so 6x is 33. X is not a whole number. I do not like this. 33 divided by 6. I do not like this at all. 5.5. It's not a weird recurring decimal though, so I may have completed this correctly. I'm just going to check I set everything up right. So this third term take away this second term. 20 minus 52 I did right there. Take away 8x plus 2. I did get that bit correct, and then below it I did put that negative to both of them, good. And then the second term 8x plus 2 take away 2x plus 23. I did connect that negative there and there. I then said that and that makes 12x, that and that makes negative 54, that and that makes 6x, that and that makes negative 21. Yeah, I'm happy with that. I took 6x on both sides, added 54 to both sides, got 33. Okay, no, I think that's fine. So now, if I put this x value into the first, second and third term, so 2x plus 23, comma 8x plus 2, comma 20x minus 52. I'm just reading the bits above. I think that's what it was, yeah. We should see something. Let's have a look what we see. 2 times 5.5 plus 25. That's the first term. 36. This one is, let's go for red. You going to work? No, you don't want to work when I want you to work. Got a love-hate relationship. 8 times 5.5 add 2 is 46. Look at that, it's got a common difference. That's got a difference of 10. I'm not liking that at all. 2x plus 25. 8. Difference of 10. Did I write them 10 down correctly? 2x plus 23. Oh, God. That is why you do not assume things. Oh, now you want to write in red. Oh, and now you don't. Oh, and you want to rub out. Brilliant. Getting trolled by your computer 101. 2 times 5.5 23. 34. It's got a difference of 12. Yes, things are going successful. 0.5 take away 52. The third term, it's 58. Now what's the common difference between these? That's 12. That's 12. We've proved that the sequence has a common difference of 12, given that it's an arithmetic sequence, so that it's a constant difference, i.e. the third term take away the second term is equal to the second term take away the third term. By making that statement, it's arithmetic. By solving it, you find the value for x, which makes the sequence arithmetic. By putting that value of x into each one of these terms, you would then solve to find, you would then, evaluate each expression, i.e. each first, second and third term, to find out what the number is in the sequence, if it was arithmetic, and if it is arithmetic and the common difference is then 12, we would see it, and it is. So I know that's been a tough and grueling paper. I hope you can use something from it. Don't forget to like, comment and subscribe. I know this is just going to be for year 11s. If anyone else is out there watching it, don't hesitate to ask me any questions. Thank you very much for listening. It's Mr. Stringer. I'm out.